This video demonstrates using Microsoft's 3D Builder program to construct a scale model using parts produced with my customizable model website, link provided below. This construction is part of a project demonstrating using customizable parts and a simple CAD tool to construct a structure model for 3D printing. The project is described in a thread at the Model Railroad Hobbyist Forum, link provided below. This video assumes you have produced the parts described in the project and have the .stl files available for use in 3D Builder. It also assumes you're familiar with basic operations in 3D Builder. If not, you can view a companion video I made that provides a brief tutorial about using 3D Builder, oriented to what we'll do in this video, link provided below. The wall we're building is the front wall of the station model, which is the most complicated wall of the structure. Here's what the completed assembly looks like. The wall is a two-part clapboard wainscoting style with various trim and a door and a window. To assemble the wall, we'll start with a new empty scene. To start construction, we'll open the .stl file of the clapboard siding part from Customizable Models. In the menu, select Insert, then Add, then Load Module. This will bring up a file selection dialog. Navigate to the directory where the .stl files are stored and select your long clapboard file. The clapboard siding part appears in the scene laying flat on the XY axis plane. At the top of 3D Builder window appears a dialog ribbon for selection of the file's measurement units. Ensure millimeters is selected and then click the checkbox Import Model. The clapboard siding's position is okay for subsequent construction, so we'll leave it where it is in the scene. Now we'll add the wainscoting part. Do the same Insert, Add, Load Model thing you did for the clapboard part, selecting the long wainscoting file. Do the same millimeters selection and Import Model. The wainscoting part appears overlapping the clapboard and is rotated 90 degrees from its proper orientation. This is because we used a horizontally oriented board siding pattern to make the vertically oriented wainscoting. To fix this, select the Rotate tool from the Modification toolbar, click on the yaw or Z axis box, enter 90 degrees in the Edit dialog, and click the Accept button. Now the wainscoting is oriented correctly, but needs to be positioned under the clapboard. To do this, click the Move icon in the Modification toolbar and use the X and Y arrows to drag the part to under the clapboard, aligning the two edges of the parts. Use the Pan and Zoom navigation to position the two parts centered in the scene. As you move the wainscoting, note how the parts snap to the bottom edge of the clapboard and then snap to the vertical edges to help you precisely place the part in relation to the clapboard. Next, we'll add trim lumber to overlap the clapboard and wainscoting. Insert Add the trim.stl file, and it should appear embedded in the wall. Make sure the Move tool is selected, then drag the trim part so it overlaps the clapboard and wainscoting where they touch each other. And then move it so one of its ends is flush with one of the wall's vertical sides. The trim board is not long enough to span the wall, but this is easily corrected with the Scale tool. Select that tool and use the arrow on the short end to stretch the trim board to the other edge of the wall. You may be asking, why are we using a 4x4 board for trim? Reason for that is this board serves a functional purpose in the model, and that is to provide a continuous volume between the two wall parts. It is not a safe assumption that butting two parts up to each other will do this. Floating point precision may produce a minuscule gap between the two, which then makes the two parts print separately. Overlapping the trim board over the two parts eliminates any such gap. And the 4-inch thickness allows the trim to lie on the floor of the X and Y axis along with the wall parts. If you give any of these parts an unintended Z or vertical axis movement, you can easily correct that using the Object Settle tool in the menu ribbon, which will lower the selected part to sit on the XY floor. Now that we have a properly sized trim board, we can duplicate it for the trim along the bottom edge of the wainscoting. With the original trim board selected, select Object Duplicate in the menu ribbon, and a duplicate part is presented in the scene. Make sure the Move tool is selected, and move the board to the bottom of the wall. Now we'll add the corner trim. With the bottom board selected, do another Object Duplicate. This board will need to be rotated 90 degrees to line up with the wall's vertical edge. Do that in the same manner as you did for the wainscoting. Move the board to one of the vertical edges like so. Then use the Scale tool to make the board the proper length. We need another trim board just like this one on the other edge of the wall. So select Object Duplicate and move that part to the proper position on the right-hand side of the wall. Next, we need to make 45-degree bevels in the wall corner edges so we can glue individual wall parts together after printing. To do this, we'll use the Subtract tool in the Edit category of the menu. This tool will take one part and subtract the material from a part it overlaps. To do this, we'll use the cornerbevel.stl file. Insert add it like the other files. First thing, it needs to be turned 90 degrees to vertical, just like the corner trim boards. Next, we need to rotate it on end 45 degrees to make the bevel edge. So we click the roll parameter, type in 45 degrees, and accept. Now, we need to move it to the wall corner in a position to subtract the bevel from the wall corner. This positioning requires us to move it vertically so that this surface covers the entire subtraction in the wall. We also need to move the whole board up in order to cover the entire corner. The final movement is the movement to put the very edge of the corner trim at the top of the subtraction. Zoom in to do these movements because you'll get more precision in the move if you're closer to the object. Now, before we do the subtraction on this corner, duplicate the part so the same thing can be done on the opposite corner. Do the same positioning of the bevel board for the subtraction. Now that you have the two boards positioned to do the subtraction, make sure the bevel board is selected and then do Edit, Subtract, and there you get a clean 45-degree corner. Do the same thing for the opposite side. At this point, we've actually constructed the back wall part, which is the same as the front wall with the door, without the door and the window. So what we can do is go to the hamburger or three-line icon at the left side of the menu, select Save As, and save backwall.stl. The remaining work to make the front wall is to cut the door and window openings and place the door and window parts. This operation exposes a limitation of the part placement workflow, in that we're just going to eyeball the door and window positions for this model. If you were constructing a model of a particular prototype, you'd have to convert your door and window spacings to scale millimeters and use those values to do the part moves down the wall. Doable, but outside the scope of this simple project. First, we'll cut the door opening. Insert Add the door opening STL file. Now note, the part comes in standing up, so we'll need to roll rotate it 90 degrees. Next, select the Move tool and vertically move the part so it goes all the way through the wall. Next, move it horizontally so it's about 3 wainscot board widths from the left corner. Next, we want to make sure the bottom is aligned with the bottom of the wall. And finally, what we want to do is select the Scale tool and add length to the bottom of the cutout. This keeps a small bit of the wall from spanning the bottom of the door opening while maintaining the full height of the cutout. Once the door opening is completely positioned, make sure it is selected, then do the Edit Subtract tool and the door opening is cut. Do pretty much the same thing to cut the window opening. This time, for some reason, Microsoft 3D Builder thinks the model wants to be in centimeters, so we need to select millimeters to scale it the right size for importing. Now position the opening centered between the wall right-hand corner and the door edge, and put the bottom right on the top of the clapboard wainscoting trim board. The last thing to do to make the front wall complete is to add the window and door parts. Note that if you made the door and window with the inset equal 1, you can print them separately and glue them in place, which makes painting easier. For this demonstration, we're going to mount the door and window in the wall for printing as a single unit. Pretty simple. Just add each part and use the Move tool to position each in their respective openings. You may notice when that comes up, I've been informed that STL files are lossy and sometimes introduce errors that don't necessarily translate into a problem with 3D printing. So you can safely either ignore that or let Microsoft 3D Builder fix this. That completes modeling of the front wall. Do a hamburger Save as, frontwall.stl, and you're all set. With all the hard modeling captured in the part generation at the Customizable Models website, the CAD wrangling to make the wall assemblies is not that hard with Microsoft 3D Builder. This placement CAD can be done with most any CAD software, but 3D Builder's intuitive navigation and tool application, as well as snap placement, make it easy to do even with no prior CAD experience. Happy modeling!